All right, everybody, let's get into congruent triangles, lesson number 2. Now, I would warn you, if you don't have lesson number 1 done, you need to go back and check it out, just because lesson number 2 will not make a lot of sense without it. We talked about how if all 3 sides of a triangle are congruent to all 3 sides of another one, then that means the 2 triangles are congruent overall, as in that means they're the same triangle. That was named the side-side-side postulate. We also talked about how you could use it with 2 sides and the angle in between. So what I like doing to start this section is I just have people list off every possible 3-letter combination that uses the letter A and the letter S. And yes, one of them will be inappropriate, whatever. We're going to cross them out anyway, so it's not that big of a deal. But the reason I bring that up is because 5 of them are actually valid. And so we need to be aware of that. We've learned about 2, and the 2 that we've learned about so far both check out. Both of them work. Now we need to go through the others. So we're just basically going to take every possible combination of letters that can be done, and we might as well just get that one out of the way. Like I said, we're just going to cross it out anyway, so it's not really that big of a deal. And there you go. These are the 8. Now, I'm going to tell you right now, this one is a no-go. We actually talked about that. You cannot prove that 2 triangles are congruent just based on an angle followed by 2 sides. So that is a no-go. That needs to go away. And this one right here is just the one we just crossed out backwards. So you can't do that either. So we're going to cross that out as well. Now, there's one other one on this list that is not actually valid for proving that 2 triangles are congruent. We learned that if 3 sides match, then that checks out. That is good. We learned that this one checks out. Turns out the third one that is a no-go is angle, angle, angle. The reason is I can make 2 triangles that have exactly the same angles as each other. And they might not necessarily be congruent. Now, you're going to learn later they are similar. I mean, they look about the same, but they are not the same size, which means they do not count. So angle, angle, angle is actually also not allowed. So since it's not, we've crossed out 3. That leaves us with 5, so we need to discuss the rest of them. So that means we have done this. We have done this. That was from lesson 1. That means now it is time to go here. So now, instead of 2 sides and an angle in between, we're going to do 2 angles and a side in between. So that's what this is going to look like. If 2 angles and the included side of one triangle. Okay. So it gets a little bit wordy. You need to write small. I may have to actually go to a 3rd line because I'm trying to type big enough where people can see. Yep, so I had to carry over to the 3rd line. Not a big deal. If you need more time writing, it's not a big deal either. You can just pause my video. This is known as the Angle-Side-Angle Postulate. And as we learned in the previous lesson, you can shorten this up to ASA. It is allowed. It is a pretty commonly known thing among the geometry world. It will not be new. It will not be something that takes your geometry teacher off guard. If you shorten it to ASA, it's pretty much just something that everybody does. So that's good news. It's always nice to have something that is pretty much uniform in the geometry universe, so that if you change schools, if you change teachers, that sort of thing, you will be good either way. All right, so hopefully you have that copied down. We'll go through an example, and we're going to show you exactly what it looks like. So let's do A, B, C right here. And here we'll just, doesn't really matter. I mean, for the sake of what we're doing, we're just going to demonstrate. So the angle-side-angle postulate means now we're talking about two angles and the included side. So basically, you have to pick two angles that match. So right here will match with right here. Then you pick your second angle. So right here and right here. And then the side that would have to match would be the included side. So it would be the side that is touching both angles. And if that is true, then you can say the two triangles are congruent. And a good congruent statement for this, remember there's no official right answer or wrong answer so much as you have to make sure the second triangle matches corner for corner with the first one. So if I am going to call this one ABC, which I will, you could have called it anything you wanted. But if you're going to call it ABC, then you have to call the next one XYZ. Okay, I had a student earlier the other day that said, well, what if I want to call it cab? You know, okay, well, that's fine. I have no problem with you calling it whatever you want for your first one. The catch is, if you're going to call the first one cab, then you have to call the second one ZXY. Okay, so both of those statements are true. The catch is you have to make sure they match. Okay. You will be marked wrong, or you may have a problem where the congruent statement doesn't actually match up with the picture, and you might think it works, and then you'll realize it doesn't. So you have to be very careful about that. All right, now this last one is technically a theorem. Now we know, generally speaking in my class, if you get the word theorem or postulate confused, I usually don't fight that battle, simply because there are textbooks that are still fighting the battle. Some textbooks will call something a theorem, some will call it a postulate. But in most of what I've seen, this next one is called a theorem, so I would like you to get used to using that term. If two angles and a non-included side. So now this is where it gets interesting. Now we have a side that is not actually included in between the two angles, so it's going to be different from the earlier picture. You have to be careful here. All right, so again, I had to use a third line because I'm trying to write big enough for people to see. So we've got, this time it's going to be two angles and a non-included side. So this is going to be called the Angle-Side Theorem. Again, this one is a theorem, not a postulate, because the side is not going to be between the two angles. Now, in most math books, you'll see this referred to as the AAS Theorem. I guess technically, backwards, that would be SAA, and it would not be mathematically incorrect, but I would much rather you just go with AAS in this case. That's just me. So let's do something that looks like this, just to mix it up a little bit. Okay, and then I'll just copy and paste that so we can have two that look the same for the sake of our demonstration here. When we're talking about letters, it doesn't really matter here either, as long as we match them when we're done. I'm going to call that DEF, and I'm going to call that JKL. Sounds good to me. So for the sake of our demonstration, I think the key here is just to make sure that when you mark the two angles that you're going to use, which in this case I think we can go here and here, and I think we can go here and here, we are not allowed to use side DE this time. Because if we did, that would be the included side. That would be the side that is touching both of the angles. So we need to choose a different one. And so we'll go with that and that. And that would give us angle, angle, side. And then over here, you could see they match. Angle, angle, side. So that's a big key there. All right, now, if you were to write the congruence statement, because it's important to practice those, you would have to say that triangle, DEF, or whatever variation you want, as long as you match it when you're all said and done, is congruent to triangle, and in this case, D would match with J, E would match with K, and then L. That would be the congruence statement. All right, here are the examples. Is there enough information to prove that these two triangles are congruent? If the answer is yes, state the theorem or postulate or theorem you would use to prove it. So we'll start over here, and I'm going to add to this. I want you to do a congruence statement as well. Don't just say yes and give a postulate or a theorem. Write the congruence statement as well so we can practice that. So we have two angles here. J is matching with L, and then this part, JUI, angle JUI is matching with angle LUI. We actually do have a side that is congruent as well because that side is shared on both. Therefore, we have an angle, and we have a side. So the answer is yes, because of the angle-side theorem. And like I said, I think we need to practice writing the congruent statements. So I'm going to say triangle JUI. And remember, I can choose whatever order I want. If you were going to go a different way on that one, it would be just fine as long as you want to, as long as when you do it, you are consistent. So again, so if I would have changed up the whole thing and I would have said triangle UIJ, it would not have mattered. So I'll go back to what I had so you don't have to erase. Triangle JUI is congruent to triangle LUI, because again, we have to match up corners here. All right, now this next one is a little bit harder to see, so we may have to make it colorful. We have a matching side right here, so we'll make the red sides match. Now what we also have is a shared side down here, and then we have the matching right angles. So another way of looking at this is what they are trying to compare here is basically the red triangle to the blue triangle. So if you're having trouble seeing what's going on because the picture is sort of hard to determine, that's what it's doing. But we do have a matching side here and here. We have a shared side. That means it has to match with itself. That is the reflexive property. And then we have the two angles that match here and here. The angle is stuck in between the two sides, which means this is actually going to be one of the ones we did in lesson number 1, the side-angle-side postulate. So what we have here, we're going to have triangle MOU, and again, it doesn't actually matter what you call it. I personally chose MOU. You could have gone MUO. You know, you could have done MUO. It doesn't really matter. I'm going to go MOU, and it is going to be congruent to triangle, and M matches with C. And then if we go straight down to the right angle, it's going to look like that. So the OU and the UO need to be in a different order this time, simply because if you follow along, it should look like this, going this way, and then like this, going this way. So we actually go in a different order with the O and the U. All right, now the final example of the day. What we have here, this is a weird symbol because we've got two symbols at once. That means these sides are congruent and parallel. And the parallel part is important because if they are parallel, then that means I can match up alternate interior angles. That means I could also do it on the other side. I could say, oh, well, these have to be congruent because they are alternate interior angles. Now, What we also have here, strangely enough, is vertical angles. So when it's all said and done, what we actually have here is more information than we need, which means we could have actually done this one two different ways. We could choose the two angles and the side that is included and call it angle-side-angle. Or we could choose the two angles and then have the side come after that and make angle-angle-side. So it doesn't actually matter. So we're actually going to put both. We're going to say yes, and we're going to say it's because of the angle-side-angle postulate or because of the angle-angle-side theorem. So either of those would work. It does not actually matter. And then when we are actually doing the statement, we are going to say that triangle car, and again, order does not matter, but we'll just go with whatever we feel like, is congruent to, and we need to match corners. C matches with O, A matches with T, and R. So triangle car matches with triangle OTR. They are congruent to each other. All right, I hope this helps you out, and I'll see you next time.